Hello, I hope you're doing good and welcome back to my channel. Today we are at problem of the day 18 for the January month, Geeks for Greeks. And we have a very good question in front of us. This question I really felt that it could test the way you are thinking about the question. And let us see what this question is. I felt really happy after solving this question. And I am making this video so that I can show you my approach, my way of doing it using Python. So let's see what this question is. So it's a medium level question called what are the plans? And if you talk about company tax, it's asked by Microsoft. So let us see what the question is. A gallery with plants is divided. First of all, see the input. See, they are giving us an array called gallery. Okay, in that some elements are present, and we are also given the length of that particular array we given to us. Okay, this is the only input given. So a gallery with plants is divided into n parts. Okay, 0, 1, 2, until n1. Okay, there are provisions of for attaching water sprinklers in each division. A sprinkler with range x at division I can water all divisions from I minus x to I plus x. See what they mean to say. See, you think of them as a sprinkler. Okay, this is a sprinkler of power 2. What that means is it can sprinkle itself. That is there, and after that it can sprinkle for two more indexes. Okay, so it will cover these two indices also, and it will cover this index and anything out left to that. If it is anything left to it, that also it can cover. Okay, that is, for example, let's talk about this first. Okay, see, it has this power of two. What that means is, see, it can cover these two indices because see, it can cover water these two belts. At the same time, it can water two belts to the left of it. Okay, that's what they're trying to say when they write two here. Okay, that's what they're trying to mean here. Okay, yeah, I minus x and I plus x. Okay, that's what they're trying to say. Now, given an array gallery consisting of n integers, okay, gallery of I is the range of the sprinkler at division I, okay. A power, see what, one more thing here is, see when the power is 0, it means that it can sprinkle only to its own area, okay. For example, if you talk about this, okay, it is at index 4, okay. So it will water itself only. It will not, water anything left of it or right of it, okay. Similarly, what is this minus 1? See, minus 1 basically means there is no sprinkler here, okay. It cannot water itself. It will need help of some other sprinkler around it, okay, to water the flowers in this particular bed. So minus 1 means there is no sprinkler. 0 means sprinkler is there, but it has a power of 0. That means it can only water itself, okay. For example, this particular index can water itself, but it can't water anything, left or right of it, okay. As simple as that. So what they're trying to say is, yeah, where gallery of I is the range of the sprinkler at position I, okay, at partition I. A power of minus 1 indicates no sprinkler attached, okay. Return the minimum number of sprinklers that need to be turned on to water the entire gallery, okay. Now see, they are talking about the minimum number here, okay. If there is no possible way to water the full length using the sprinklers, return minus 1. So let us try to understand what they are trying to say this. Okay, see now, let us begin with this example first. See, try to understand it. If I use this sprinkler, what will happen is I will be able to cover these two, and I will be able to cover these two beds. Okay, and at the same time, it obviously will water itself also. So in total, if I use this particular sprinkler, I will be in a position to water all of these five. Okay, now one thing is remaining. Okay, so this thing can water itself. Okay, it has a power of 0. That means it won't be in a position to help other beds around, surrounding it, but it can water itself. So at max we need two. Okay, that's what they're trying to say here. We need two, two sprinkles on the minimum to water all the beds. Okay, which are the one? This is the one, and this is the one. Okay, though they are not asking the indexes of the sprinklers, they're asking the numbers. Okay, how many we need to turn on, and that answer should be minimum. Okay, return the minimum number of sprinklers that need to be turned on. Okay, that's what they're trying to say. So as you can see, index 2 and index 5. That's what it is. This is index 2, and if you talk, this is the index 5. Okay, yeah, this is the one. Now coming to example 2, you can see here that they are saying the index 7. Okay, index 7 cannot be watered by anyone. Okay, see, try to understand this fact. See, the maximum possible thing is 4, right? What 4 means? It will be in a position to water these 4. Okay, it will be in a position to water these 4. Okay, no one else could even reach here. Okay, because the left of it are even smaller ones, and similarly the right of it are even smaller ones. Okay, similarly, if you talk of these two, it will also be able to water till here only. This 4 also can water till here only. None of them can water this particular thing. Okay, it is minus 1. That means there's no sprinkler here. It needs someone, sprinkler of a neighboring partition to, water it. Okay, it do not have a sprinkler on its own. But what are the neighbors? 0 is the neighbor. Okay, that means this particular index has a sprinkler, but it won't be able to supply water to the neighbor. Okay, so this particular index cannot get water from anywhere. That's why we're returning minus 1 as the answer, because see, they have clearly mentioned that. Okay, if there is no possible way to water the full length, simply return minus 1. So yeah, these were some of the questions. Maybe you can go through the other questions as well. For example, if you talk about this thing, see, it has 4 here. Okay, what that means is These two are anyway covered. Apart from that, these four are also covered. Okay. Once I cover, see, that means if I take this particular sprinkler, it will cover all of these. Okay, all of these. So how many are remaining? Two are remaining. Will they be able to water themselves? Yes. So 1 plus 2, which is 3. 3 is the answer. Okay. That was all about it. But now comes to how we are going to solve it. Okay. See, try to understand this fact. What is making us decide what to choose? One thing is very simple. From where we are starting. Okay. Obviously, we are going to start from zero only. Right? See, ultimate aim is we have to cover everything, every index. Okay. And the second other important thing is we have to cover it in a minimum possible number of sprinklers. So if we combine these two factors, try to understand this. See, the idea here is uh, we have a requirement of a starting index. Okay, so definitely we need those sprinklers which can water my starting point. Okay, that is one requirement. The second thing is if there are more than one options, what I'm going to do, I'm going to take the sprinkler which has the maximum range. So that's what we are going to do now. Try to understand this fact. See, I'm going to take a range variable. See, in Python, whenever you do things, always remember, always try to add. See, this I am trying to add extra. Why? It means, see, range is actually a function in Python, by the way. Okay, so you should not be taking a variable whose name is same as that of a inbuilt function. So the best way to ignore the avoid such a ambiguity from happening is just add a last letter again. Okay, so I'm always doing that. Okay, this is a practice I will always do. Okay, so this is the range variable. Okay, what I will do, go through the gallery. Okay, go through the gallery unless the gallery is -1. If the gallery is -1, don't need to do anything. Okay, other than that, go to each of the index. What you need to do, subtract. Okay, I minus gallery of I. Okay, I minus gallery of I, do that, and the other one is I plus gallery of I. Okay, so this is the basically a range. Okay, in which this particular index can water. Okay, so I'm doing that range. Remember one more thing, if this range is getting negative, okay, that is the left index is getting negative, so stop it at 0. Similarly, if the right index is crossing n-1, stop it at -1. This is what we are going to do. Let me quickly print and show you how it looks. See, this thing is whole about imagination. Okay, how if you don't imagine, it will be difficult for you. See, this is how it will look basically. Okay, remember, see, this example you may not be getting by default if you try and segment the code. So I have taken this example because it has negative values and it has zeros. That's why I'm taking this example. By default, you will get some other input. This yeah, custom input. We will have to give this. Okay, so now try to understand the fact here. See, there are six integers here. Okay, but how many are we are having? Total 4. Why it's like that? See, this -1 and this -1 are not going to contribute anything, so we are simply ignoring them. Okay, now come to this fact. Come to this 2. What is the range of this? See, it will start with 0. Why? See, 2 means it will cover this index and it will go one more beyond. That is not possible, right? So we are starting with 0. Okay, so it will cover this index, which is 1. 1 plus 2 is 3, so it's index 3. Okay, same for this, it will go till index 4. Okay, now come to, yeah, this thing, it will cover only its own index. Similarly for this, it will cover only its own index. Okay, this is the one. Now what I will do is, see, try to understand this fact. I will need to do, see, I have a requirement of starting point. Okay, once I'm at the starting point, I will try to see which all are covering the starting point, and from among them I will take the one which has the maximum length. Okay, maximum range. So what I will do, I will sort them based on the starting point. Okay, so this is how I'm doing it. I will sort them based on the starting point. So what is my starting point in this basically? See, the first index is the starting point. Okay, the zeroth index is the starting point. The first index in each of them is the ending point. Okay, so again, I will do that. Okay, so the sorting will happen based on the starting point only. Okay, so after sorting it, it will look something like this. Okay, in this case, there is no change here, but in other cases there will be a change. Okay, so what will happen now? This is sorted based on the starting point. Okay, so now one thing is very clear. Try to understand this. Now, since they are sorted in the sorting order, what it will happen is, see, since see, for example, remember one thing, the range which we are calculating and the array given to us, that is the gallery array, will have may have different length. Okay, for example, if -1 is present in gallery, for that we will not have a corresponding range present in the range array. Okay, so for range array, I'm going to take a separate length which will be m in this case. Okay, now I will have starting point called 0. Why I'm taking the 0? Try to understand this. I will have to cover all ranges. Okay, see, it's a requirement in the question. So in this case, I will start with 0. I will try to see which all the ones are covering 0. Okay, for example, in this case, these two are the ones which are covering 0. I will stop here, and among them I will take the one which has the maximum length. Okay, that is the basic idea. That's what I'm going to do here. Okay, so what I'm doing, I'm printing start. Okay, okay, let me quickly trace and show you, that will be bigger. So what we are doing, we are starting with 0. Okay, we are considering this index first. Okay, yeah, it is a satisfying one. Okay, we are fine, good. Next index is also starting with 0, so we are considering that also. Okay, so I of 1 is also considered. Okay, now among them which has the maximum range, obviously the one which is ending with 4 has a maximum range, so I am setting the end to 4. Okay, and which is now set to 4. Okay, since we are done, we are incrementing the answer by 1. Okay, what will the start? Now start will be always n plus 1, so now we are going to start with 5. Okay, now I'm at I is equal to 2. Okay, these two indexes are covered. Yeah, these two are covered. I will not cover them again. That's why I've sorted it, right. So I will now consider this index. Now I'm at I equal to 2. What is my start? Start is 5. Is 5 in this? Okay, obviously 5 is greater than the end of this. So no need to consider this at all. Okay, go next. Okay, I will go to I equal to 3. Is 5 in this range? Yeah, 5 is in this range. Okay, so yeah, I'm done. So I will end it. So the end of it will be the end of this. As simple as that. Okay, we'll stop now. And yeah, this is going to be our final answer. Okay, so I will quickly show you what I'm doing here. See, this loop will continue till start is not equal to n minus 1. Okay, as simple as that. Remember one thing, since I have done this already. Okay, see, the range of everything is being set to n minus 1 at the max. Okay, so always there will be a case that we will be stopping it to n minus 1. If you are not stopping, then I will simply conclude that it is not possible to cover all the indices. Okay, then what I'm doing, always I'm declaring n as minus 1 for each iteration. Okay, then till I is less than equal to m, remember I will remain. I is declared here. Okay, so its value will remain even after the while loop completes. Okay, so what I'm doing, see, I'm simply checking if start is in this particular range. Okay, that is start is greater than the 0th index and start is less than the ith index. Okay, less than or equal to, greater than or equal to. Okay, that's what I'm checking. Start is greater than or equal to the 0th index, start is less than or equal to the ith index. Okay, if that is the case, it could be a possible answer for us. It could be a possible option. So I'm doing n is equal to max of any other end or the range of I of 1. Okay, remember I of 1 is the yeah, range of I of 1 is the end of that range. Okay, I am doing that. Now comes to the case where, see, suppose in this case, see, try to understand this fact. Start may be greater than this. See, when it will not go to this, as you saw the case here. See, for example, in this case, I have suppose taken this range. Okay, what will mean start? Start after taking this will be 5 because it will be n plus 1. Okay, 5. But is going to start greater than the start of this? Yeah. But is 5 less than or equal to end of this? No. So in that case, what I will check is, see, why this condition will fail now? Because this is not being satisfied. Okay, 5 is not less than or equal to 4. So in this case, I will again check if start is greater than in the range. If it is greater than the range, simply skip it. Okay, do I is equal to I plus 1 and continue. Okay, that's what it is. So that's what we are doing here. See, once I take this range, okay, 0 to 4, I need not consider this because 4 is already covered here. Okay, as simple as that. That's what I'm doing. Okay. Yeah. Remember, if anything else, what I'm trying to say is, see, there could be a case. So for example, let us say we have a range of 0 to 3, and then the next range is from, let us say, 9 to 12. So in between there is nothing. Okay. So that's why again there will be a case where this is not satisfied. In this case, I have to break. Okay. So in case if start is between any of these ranges, remember at least n will be some value other than minus 1. Okay. So that's what we are checking after we come out of this loop. Once we come out of this loop, we are checking if n equal to minus 1. In that case, see, if n is minus 1, that means the start was in none of these ranges. Okay. That means we cannot water all the plants. So we'll return minus 1. If we are not running this code, then definitely we have chosen something that is and is definitely not minus 1. That means we have chosen some range. That's why we will increase the answer by 1 and we will make start equal to n plus 1. Okay, so that is the basic idea of this particular answer, and finally we're returning the answer. Okay, yeah, that is the one. So I hope you understand what we are doing here. If you want, I can quickly run and show you also. But yeah, if you want these kind of outputs, maybe I can give you that. That is fine. But yeah, I will just quickly run and show you that this solution works. I've already submitted this solution. If you want, you can try it out too. Okay. See, my point is to explain you the logic how I'm doing it. Anyway, you will have the code in the comment section. Okay, in the comment section of the video, so you can go through it. But see, my aim is to like give you the idea in the shortest possible time. Okay. So as you can see, the answer are getting accepted. Remember, in the original test case which you will be given, I think you will be given 8 here and some array will be given. In that, you will not have zeros or minus ones. So that is definitely not a good, test case to begin with. As simple as that. So I hope you understand what we are doing. See, the requirement is we have to cover all the indices, and the second requirement is that we will have to take the minimum number of, possible number of sprinklers. So how to ensure both of them? We are taking the range and we are making separate array. We are sorting it based on the starting length, and then once our start is fixed, initial start will be 0. Then we are proceeding further. Once a range is explored, we are not going to back. We are going back to it. Okay, as simple as that. And how we are ensuring that we are taking the minimum number of sprinklers? We are taking the max range. Okay, once see, for any starting point there may be 4 or 5 ranges which are including it. Out of them we are taking the one which has the max range. Okay, that is a max endpoint, as simple as that. So that's what we are doing here, as you can see in this part. So please go through the solution. If you have anything, please do come up. We can discuss it further. This was a very very good question. And remember, ideas are worth the. See, it's all about ideas. Okay. See, it's only worth it if you are getting the ideas. Okay. It's coding part. May see coding part you will get it after some practice, but ideas are something which you may not get. Okay. See, you will have to work on ideas only. This question can be, see, the code is not something very difficult here. Okay. It's all about if you are having the right idea or not, and if you are having the right idea, if you are having exact details of it, what we are going to do in each of the cases. Okay, so in this case, as you can see, I have 3 conditions here. Okay, so all these things we'll have to think and then you will have to code it. So if this comes in interview, see, definitely this kind of questions will come. Okay, see, in this case there's no great algorithm involved, no graph or tree kind of algorithm involved, in which if you don't know the basics you won't be able to do. It's not like that. It's all about thinking. Okay, definitely expect this kind of questions, and as I've already mentioned, this question is from Microsoft. So please do spend some time on it and try to understand what is exactly happening. I've already explained you the logic. So yeah, friend, that was all for today. If you have a better solution, please do let me know. We can discuss it further. And if you like my efforts, please subscribe to my channel. It definitely gives me motivation to continue further. Thank you, everyone. We'll see you tomorrow.